Question 10.28. A 2 microfarad capacitor is fully charged by being connected to a 12-volt battery. The fully charged capacitor is then connected to a 0.250 Henry inductor. Calculate the maximum current in the inductor and the frequency of oscillation of the LC circuit. So here in this question we have capacitance C as 2 microfarad, which can be written as 2 times 10 to the power negative 6 farad. Battery voltage V as 12 volt. Inductance L as 0.250 Henry. And we need to find what is the maximum current through the inductor and the frequency F of oscillation. Now you can find the maximum current through the inductor if you know the maximum energy through it. And maximum energy across inductor is given as half L I max squared. Now we also know that maximum energy across capacitor and inductor are the same. That means UB max is equal to UE max. And this is because initially all of the energy is across the capacitor, and when it is connected to inductor, energy is transferred from capacitor to inductor. The current becomes maximum in inductor when the capacitor is completely discharged. And when the capacitor is completely discharged, all of its energy now has been transferred to inductor. So you can write this to be equal to UE max. Now UE max you can calculate by using the rule Q naught squared over 2C, where Q naught squared is the maximum charge across the capacitor. Or you can also get this energy as half CV squared, because we know that charge Q can be written as C into V. So let's substitute. We get half Li max squared to be equal to half CV squared. I'm using half CV squared over here because we have the capacitance and the potential difference, not the charge. Now cancel off the halves from here. I need to find what is I max, so we will divide by L. We get I max squared to be equal to CV squared over L. Now take square root on both sides. I max will be equal to square root CV squared over L. Now we substitute. Square root capacitance is 2 microfarad. Potential difference is 12 volts, so 12 squared over L, which is 0.250 Henry. That gives you the maximum current to be equal to 0.0339 ampere, or you can also write this as 33.9 milliampere. Then in part B, they want us to find frequency of oscillation. We know frequency and angular frequency are related as omega naught equals 2 pi f. So f will be equal to omega naught over 2 pi. Omega naught is given as 1 over square root LC. So we substitute that here. F becomes equal to 1 over 2 pi into square root LC. Now let's plug in the values. F will be 1 over 2 pi. Square root L is 0.250. C is 2 microfarad. And when you solve this, you get frequency F as 225.19 Hertz. Or you can also write this as 225.19 second inverse.